So this is something, and I've said this before. This is not the first time I've said this, but this is stuff that you had probably at the latest in Algebra 1. You might have had a little bit of this before you took Algebra 1, but I would say definitely Algebra 1 is the first time where you hit this really hard. You definitely did this stuff in geometry. I teach geometry all the time, and I taught Algebra 1 as well, and in fact in Algebra 2. So in Algebra 1, geometry, and Algebra 2, you've had this kind of stuff, and we've mentioned this last week, but now we're actually getting into it. So we talked about the slope of the line the other day, didn't we? Right? But we're gonna talk now. That slope of the line is really gonna come into play here with the equation of a line. And we've mentioned what the equation of a line is, but I just want to go through it again. So the equation of a line. Does anybody remember what the basic form of an equation of a line? Probably the one that you memorize and have down pat, and you'll probably always at least remember this.
Y equals mx plus b.
You got it. Y equals mx plus b, right? I bet you somebody that took algebra 30 years ago, all right, if you mentioned to them y equals mx plus b, oh yeah, I remember doing that. Now, they may not remember what all this stuff stands for and how to do it, but they probably remember that phrase, y equals mx plus b, because you had it so much, all right, all through high school. Even if you weren't a good math student, most people remember at least that phrase, y equals mx plus b. Anybody in here remember that phrase from earlier days? Yeah, absolutely. Okay. So what we're going to do is let's talk about what all these letters represent. And let's do a couple. Let's do this one. We've talked about this one already. Remember, this is a line. This represents a line, just a straight line. Okay, no curves in it or anything like that. Just a nice straight line. And that letter right there represents something. We've talked about it already. Exactly, and that's the slope of the line. We know a bunch of stuff about slope. Okay, we just talked about it not too long ago. We said it's the change in y over the change in x, or y1 minus y2 over x1 minus x2, or rise over run. All kinds of different ways that we talked about the slope. All right, it's how much it slants. We have positive slopes, negative slopes. We have zero slope. We have no slope. And looking back on it, I think I might have to go back real quick and talk about zero slope and no slope, but we'll do that in a little bit. Another letter that's really, really important here is this letter. It's the letter B. Now, it's kind of weird that they would give it the letter B, but I'll tell you why they give it the letter B in a second. Does anybody remember what that is off the top of their head? It's the Y-intercept. Good. So you did learn that stuff. So I'll just put well, I'll write the whole word since it's the first time I wrote that. Okay, it's called the Y-intercept. Now, what does that mean? To be the Y-intercept. Exactly right, where it crosses the y-axis. So if I had a line, and let's just draw the line right here, that red line right here. If I wanted to point, if I told you, take your pencil and point, or put a dot at the y-intercept, where would you go? You'd take that red line, and it's where it crosses the y-axis. Well, which one is the y-axis? Right, it's this one. It's the vertical one, right? So that's the y-axis, and of course the other one is the x-axis. So if I asked you to put a point or a dot where that red line crosses the y-axis, where would you put it? Put it right there. Okay, so that point right there is this. It's the y-intercept. Now, if it's the y-intercept, how's that always going to be written? It's going to be written what? 0 as an ordered pair, right? But since it's on the y-axis, what's your x point always going to be? It's going to be 0 and then whatever the y point is, and we'll just call that b. Is that all right? Now, why do they use b? Well, because guess what this would be called then, this point right here. If this is the y-intercept, what do you think this is going to be? It's going to be called the x-intercept. And guess what point they assign to that? Let's take a wild guess. Well, it's not 0 because you got to go this way first. Right, it would be a0. So they use a for the x-intercept, and so guess what they use for the y-intercept? They use b. So that's why they put the b in there, because the two intercepts are A and B. A is for the x-intercept, B is for the y-intercept. We just don't use the x-intercept all that much. For some reason, they really love the y-intercept, so that's what we use. Does that make any sense? All right, so that's why it's a B. Did you always wonder why that was a B? I mean, y-intercept, and that's a weird letter just to pick, but that's what they pick, because A for the x, B for the y. All right? Does that help a little bit? All right. What about, actually, let's keep that in here. What if let's go blue here. What if I took any random point on that line right there? Any random point, like a point right here. Okay, it's not on the y-intercept, or it's not on the y-axis, not on the x-axis. It's just some point on that red line right there. Well, I would call that point right there, just call it xy, because I don't know where it is. Okay, but the xy represents any point that lies on that red line. Everybody see that? So that could be my xy. So what does that mean? That point right there, that x part of that point, right? I go over x and I go up y. That could be right here. The x part could be here and the y part could be right here. So what does the x and y represent? It represents any point that's on that line. Did I just say any point in the world? No. It can't be like this point out here. That wouldn't work for x and y. What does it have to be? It's got to be a point where? On the line itself, okay? So that xy represents any point that is on that particular line, okay? So let's do a little bit with this. Let's see where I want to go with this. Oh, by the way, let's write that y equals mx plus b again. They have another little bit of a fancier name for this. This is not the only equation of a line. There's several different forms of an equation of a line. This is kind of the one that's probably the most popular, at least for high school kids. Okay, that this is a certain form of the equation of a line. And since it has a slope, and since it has a what? Intercept. Now it's the y-intercept, but it is an intercept, okay? So since it has a slope and it has an intercept, guess what form of the equation of a line we're going to call this? It's written right there. What is it? What do you think? The slope what? Intercept form. Exactly right. Okay, so we call this the slope-intercept form of an equation of a line. Now again, there's several different ways to represent a line, a straight line. This is just one of them. All right, there's several different ones. Okay, this is just one of them, but this is probably the most popular one, if you want to rank it in popularity. All right, so that's probably the most popular equation of a line, and that's this one. It's the slope-intercept form, y equals mx plus b. All right, so I wanted to throw that out at you because sometimes you'll see that. Let's see what I can do with this. What if let's start off easy. They don't do this. They start off with something else, but I'm going to start off a little easier than they do. What if they give you an equation of a line? I'll make this really simple. What if they give you that? Now that's slope-intercept form, isn't it? It's y equals mx plus b. Well, what's the m in this? What's the slope when you just look at this equation right here? You should just be able to look at it and tell me what the slope is. It's 3, right, because the m is the slope. Where's the m here? It's the number that's being multiplied by x. Would you agree? So the m is the 3. So the slope is 3. Now we do rise over run, so it's going to be 3 over what? 1. Good. And what else does this equation tell you? The intercept, the y-intercept. So what's the y-intercept here? It's 2. Or if we're going to write it as an ordered pair, what would that be? 0, 2. Right? Remember we did that a little earlier? Okay. So now let's go and draw a little graph. And what if I asked you to graph this thing? Shouldn't be too hard because now you know what the y-intercept means. We've already talked about slope, so you know how to do the slope. You had a whole worksheet, didn't you? Where you had to put a point and then you did the rise over run to get a line out of it. It's exactly what we're doing right here. So it's really not much different. So first thing I start at is the y-intercept. I don't start with the slope. I always start with a point. We've got to have a starting point. So the y-intercept is 0, 2. So I'm going to tell you what, let's put a few more points on here so I don't have to rewrite them again. All right, and let's do a different color so it stands out a little bit. So the y-intercept is 0, 2. So 0, 2 would be right there. It's where it crosses the y-axis, isn't it? All right, so you look at this. That tells me where my line crosses over the y-axis at positive 2. Now what else does this tell me? It tells me the slope. And so starting at that point, figures I didn't put enough points in there. Okay, starting at this point right here, I've got to rise and I have to run. So starting here, what do? We rise what? It's 3 over 1. This is rise, and this is run. Okay, so we rise 3, starting at this point. So we rise 3, 1, 2, 3, and we run what? 1. That means we go to the right, right? Positive 3 means we go up. Positive 1 means we go to the right. Now what do we do once we get those 2 points? We just connect them, right? Now don't just start from there to there. Don't do that, all right? Technically it wouldn't be wrong, but it just doesn't look quite right. Extend it beyond both of those points. It just looks a little bit better if you do that, that's all. Technically, it keeps going, so technically you should have arrows at the ends of it. I wouldn't mark it wrong if you didn't. Most of the time, I don't put the arrows at the end of it. It's just kind of assumed already that you have arrows at the end because it's a line. It keeps on going. It doesn't just start and stop right here and here. Okay? And what did you just do? You just graphed that line. Okay? What if let's just go a little bit further with that. What if they asked you to do this? What if they asked you to graph? I'm just making this up again. What if they asked you to graph that? Tell you what, I'm gonna let me change a number here. Is that all right with you? Just to make this come out a little bit easier. What if we had that? Let's do that. If I asked you to graph that, would you just be able to say, oh, that's the slope, that's the y-intercept, bang, bang, you put the points and you graph it? No. Because it's not in what form? It's not in slope-intercept form, is it? So one of the best things to do is to actually put it in a slope-intercept form. Remember what slope-intercept form is. It's y equals mx plus b. So basically, what are we going to do with this whole thing right here? We're going to solve for what? We're going to solve for y. We want to get y by itself, don't we? Okay, that way, if I get y by itself, then I'll be able to look at it and just tell which one's my slope and which one's my y-intercept. So let's do that. Actually, I should have done another number. That's okay. It's just, I wasn't thinking. I shouldn't have changed that one. I didn't care about that one. Let's change this to 2. All right. Sorry about that. And I'm killing you here, I know. But you haven't started this yet, have you? So let's keep that when I originally had it. All right. You got an eraser, right? And that's the nice thing about doing it in pencil, right? All right. So let's do this one. Okay. Sorry, I got mixed up. That's what happens when I make up my own problems here. Let's do this. Let's solve for y. So let's write this again without all the junk around it. And what are we going to do first? Well, we got to get rid of that 5x first. So we subtract it from both sides. Now watch what I do. Remember, I want the x in front of the regular number. So I'm not going to go -2 minus 5x. We talked about this the other day. I'm going to slide it inside of here. So it's going to go -5x minus 2. See what I just did? I subtracted a 5x from both sides. Subtracted a 5x. But I didn't put the -2 first. I just switched the order. I went -5x minus 2. Now, why did I do that? What's the big deal about having the x first? Because I want it to fit this formula. Okay, this formula's got the x first, doesn't it? And then the constant on the end. So that's how I want to write it. So what I did is I just kind of took that -2 over. Watch, since I've got this program, I can show you what I did. Let's get rid of all this junk. Watch. What I did was this. I took that -2. I just slid that over. You with me? Okay, and then I took this. I put it on the other side. But what do I have to do when I put it to the other side? Got to make it negative. See that? So that's what I did. All right, now we're not done yet. We want to get y by itself. So what do? Divide by 2, divide by 2, divide by 2. Divide everything by 2, not just the slope. Right? Not just the thing with the x, not just the number. Divide everything by 2. So let's see what we get. We get y equals -5 halves x minus what? 1. Now the reason I changed everything around because I wanted that y-intercept to come out to be a nice whole number. It doesn't have to be a whole number. I just thought it would just be a little bit easier for us. So that's why I mixed everything up earlier. So now, if I was to ask you to graph this thing, which is the original intent of this. 2, 3, 4, 1, 2, 3, 5, and 1, 2, 3, 5. Okay, so let's plot this thing. First of all, the y-intercept, that's what we want to do first, and it's -1. Let's do this in red. So -1 is right here, so I put the y-intercept at -1. Now you have to look for the slope. Here's the slope. Remember, it's -5 over 2, which is rise over run. You shouldn't have to write all this stuff down. I'm just doing that so you can visually see it. So what is the rise? It's -5. So if I'm here, what's -5? It's going down, right? Or I could write it, watch this, I could write it another way. What's another way I could write -5 over 2?
-2.
How about 5 over what? -2. Isn't that the same exact thing? They both come out to be negative, right? -5/2. Why would I even mention that? Because sometimes if you don't have enough room down here to go down, so this would mean I do what? I go down and then to the right. What would this mean? I go what? I go up and to the left. Both of them are still going to lie on the same line, and I'll show you. So let's go down one more. So if I went down 5, 1, 2, 3, 4, 5, and I ran 2, 1, 2, right there, or I could do this. I could have started here and rose 5, or risen. What word do I use there? I could have risen, right? Or I could rise 5, 1, 2, 3, 4, 5, and run what? -2. So I have to go to the left 2. But look at all these. What do? They all line up, don't they? Now hopefully they line up. Yeah, it's pretty close. And we'll extend them out just a little bit, just like that. And there's your graph right there. It's got a slope of -5 over 2. What's that? There's not really both answers. There's only one answer because there's only one line, right? So there's really not two answers. There's just two different ways you could get to that second point, all right? And I don't care. You could go down, right? You could go down and to the right, or you could do what? Go up and to the left, all right? Either way, it still gives you the same exact line, doesn't it? All right? Make sense? Okay. I think I just want to stop with slope-intercept form. There's another form. There's actually maybe a couple more forms that we're going to do, but I'm just going to stop right there because I just want us to get our brain wrapped around that. Here's one more. We got a couple minutes. Let's do one more problem. This is a little bit more difficult. This one says find the equation of a line. So we're not necessarily graphing this one. It says find the equation of the line that passes through these 2 points. So they're going to give you 2 points, and 2 points make up a line, don't they? And they want you to figure out what is the equation of that line in slope-intercept form. So yeah, I'll use these points. -3, 2, and 2, -4. So look at this. You want to find the equation of a line. They'll probably tell you which form. So we're just going to say in slope-intercept form. All right. So find the equation of a line in slope-intercept form that passes through these 2 points right here. Now, you could, I guess, graph it and then figure out where the y-intercept is, right, if it crosses right through. What if it crosses like in between a couple numbers? And you'd have to guess, wouldn't you? You don't want to do that, okay? So I am not suggesting that you graph this first. What I'm suggesting is that you use this thing right here and understand what you're finding. You have to find 2 things. You have to find the slope and you have to find the y-intercept. Let's find the slope first. Now, we did this earlier. Not today, but we did this in another lesson. You can find the slope if you know 2 points, can't you? So let's do that. So find the slope. It's the change in y over the change in x. So you subtract the y's. So it's 2 minus -4. See that? 2 minus negative 4. And then you subtract the x's in the same order. So it's negative 3 minus 2. Negative 3 minus 2. 2 minus negative 4 is positive 6, and this is negative 5. So your slope is negative 6 over 5. Right? Now remember, you could write it with a negative out in front if you wanted to, or if you wanted to, you could put it negative 6 over positive 5. I'm going to write it like this, though. So that's our slope. Now what we have to do is find our y-intercept. Now sometimes this is where it gets a little bit tricky for some people to find that y-intercept. Let's do this y-intercept in a different color. I know my slope now. It's negative 6/5. And I also know an x and a y. What did I say earlier what was true about this x and y? What does it represent? It represents a point on a line, right? On our line. Well, guess what? I have 2 points on our line, don't I? So I can either use this one or this one to put in for x and y. Because it represents a point on the line, I know 2 of them. I could put either one of those in for this. And it doesn't matter. It doesn't matter which one you choose. You're still going to come up with the same answer. So do you have a preference? Let's just pick one. Let's pick negative 3, 2. All right, so what we're going to do is we're going to pick this negative 3, 2. Now when I say we're going to pick it, what are we going to do? That means the x, plug it in, right, where x is negative 3 and y is positive 2. And we already know the slope, though, don't we? So we're going to plug it all in and then solve for b. So let's do that. So what's our y? 2. Equals m, we just found that, it's negative 6 over 5. Times x, what's our x? It's negative 3. And then plus, what? B. We don't know what our y-intercept is. And now, this is where people get, this isn't really rigged to come out super easy for you, but just watch what we do. 2 equals, nothing cancels out here, so that's positive 18 over 5 equals, oops, not equals, plus b. I want to get b by itself, so I subtract 18/5. So I subtract 18/5 here. Now let's change 2. I want a common denominator, don't I? So I'm going to write it 10 over 5. Why did I pick that? Because my denominator is 5. So 10 over 5 minus 18 over 5 is negative 8 over 5, and that is my y-intercept. Not a very pretty number, is it? All right, but that's what our y-intercept is. If you were to graph this, there's probably no way you would have guessed. And what is negative 8 over 5? It's negative 1 3/5, isn't it? That's where it crosses the y-axis, at negative 1 3/5. And if you would have graphed it, I really doubt that you would have guessed that that would have been your y-intercept. So we put it all together now. There's our slope. There's our y-intercept. I'm going to keep it like this. See those two things that are circled? We put it all together and we write it y equals m, negative 6/5, x, and then b, which is negative 8/5. And that's how you would write the equation of a line that passes through those 2 points. Went a little quick down here, but it's just common denominator. That's the only thing really difficult about this, I think, is just knowing what your common denominator is and subtracting, and it really shouldn't be that hard or that difficult. All right? So that's all about slope-intercept form. Tomorrow we'll talk about another form and talk about lines being parallel and perpendicular and different things like that, but I think that's good enough for today. I'll just give you your worksheet tomorrow because some of the stuff that we're going to teach tomorrow is on this worksheet. All right, so I'll just give you that tomorrow.